Okay, let's talk about the basics of Vellum, and we've already seen a lot in the last video. So the first thing we've seen is that we need a Vellum solver, and that is this DOPS in SOPs concept. So this is a DOP network inside, and all kinds of presets to make our life easier. And if you run this now, it doesn't work because it expects a second input, which is a constraint. So we need another node, and here you can see when I type in Vellum, we get all kinds of nodes, and we will look at, I think, almost all of them. And what they mostly handle is constraints. And the most important thing here is the Vellum configure cloth that we need to prepare the constraints. And this is not used in all of them, the Vellum cloth, but it's the basis for most of the simulations for Vellum. So what this does is, first of all, you can see now it runs. And as we've seen before, we can also put in a collision object. Make sure it's a geometry, and you can put that in here like that, so that you can see you have a highway of data that is already prepared, so to keep everything convenient and clean. But by the way, you can also, because it's just a pass-through, use the collision object directly at the third input of the solver, and that will work as well. So let's talk about the really new thing here, and that is the constraint. So what a constraint is and what this node here does is the following. You have a normal grid here, and when you look through the Vellum cloth, you can see that it now creates additional geometry. It's important to note that what you see here when you look through it is not the geometry that comes out of the first input. So let's make this clearer by using a couple of null nodes. So here from the first input, actually not much has changed. What we got is, before we didn't have any attributes, and now we have a couple of attributes that this node creates on the geometry itself. For example, mass and all kinds of stuff like p-scale, which is important for the collision later on. But the most important thing is actually what comes out of the second input, which we see at the same time when we look through the Vellum cloth, and that is the constraints. And what this is nothing, no new geometry or anything. This is actually normal geometry that we already know. It's curves and points. And we can actually change, if we middle click on it, we can see that, and we can actually change that if we want in any way we already know. For example, even though it doesn't make sense, we could use a mount node to kind of deform that, and maybe you need that. It's kind of cool looking. But of course, that's not the point. The point is what this is for. And that is basically the relationship between the points on the input geometry. So what does it mean? So on the first input, you can see on the geometry, for example, those 2 points here, when we run through the Vellum cloth, get a constraint. I'm not sure which points I chose, but let's take those 2 here. There's now a curve between coming out of the constraint output. And that defines that there's a relationship between the two. And it's actually quite simple. It means, you know what, I want to keep that distance that I have right now. And the goal of this is that if I run my simulation, that my cloth is not falling apart, basically. Let me quickly create a new collision object. If this cloth now falls down, the constraint defines that those points try to stay together, so that there's some resistance when you try to tear a piece of cloth apart. And this is what a constraint is representing. It's a relationship between the points. And we will talk about this a lot because constraints are super important and they will play a role later on in other fields as well. But keep in mind, it's a relationship, and it's actually multiple relationships at once. For example, in this case, it's not only the distance that they try to keep, but also the rotation that they have. So you can define the stiffness of the relationship. And this is actually something you find in the Vellum cloth under, who would have thought, stiffness here for 2 things. Stretch and bend are the most important ones. And again, stretch is the distance between the points, and bend is the rotation around each other, so the angle between them. So we could also call that distance stiffness and angled stiffness. And when I change this, for example, I increase the bend stiffness, and Vellum, the new version of Vellum, has this drop down here that is a multiplier to reach very high numbers easily, which sometimes you need. And if I increase that quite a lot, you should be able to see that now my cloth is way stiffer so it's fighting the bending more. If I lower this back to something really low, maybe not 0, but something really low, then it resists way less to bending. Not sure if you were able to see that here in this example, but this is something we'll talk about a lot. So the most important thing is that we need first a constraint configuration, which you can actually combine. So later on we will see we have multiple of those constraints combined. For example, if you have a cloth that you want to tear apart or that you want to sew together or stuff like that, you need additional constraints to represent that. But this is then put into the Vellum solver, and here the Vellum solver calculates those constraints against the forces that are applied to it, and in the end comes to a result. So that is the basics, and we will talk about all this stuff in the next couple of videos: forces, collision, plenty of talk about constraints, but that's just as a general overview for you to start right away. All right, I hope this was helpful. Thank you very much. See you later.